All right, welcome everyone to today's SQL workshop. So today we'll be covering the basics of SQL. And what we'll be doing is that in addition to any class workshop or classroom, this workshop will focus on how to actually work with SQL functions to create analytical data set in a professional or a research career and lifestyle. So we will learn SQL using SQLite, which is the SQL, one of the versions of SQL. There are many flavors of SQL, such as there is Netezza SQL, which is generally used by Optum, and there is MS SQL, which is popularly used by different companies, including our very own AHCIE's database, which uses MS SQL. And there's Oracle, and there's T-SQL. Now, all of these different variety of SQL have one thing in common. They are structured query languages, which is S stands for structured, Q stands for query, and L for language. They have a standard format, and that standard format is consistent throughout. The only thing that changes within this different variety of SQL is how we structure that language. So any tricks that we are learning in this workshop equally applies to Netezza, MySQL, MS SQL, and so many other SQL's variety. Now, to use that, we will be using DB browser, which uses SQLite version of SQL. And as the name says, SQLite, meaning it is not very resource intensive, yet it has all the features and functionality of a SQL. Any questions so far? Okay, I'll take that as a no. Thank you. Emojis work too. So first thing, have you all installed DB browser? Yeah. Yes. Thank you. Link, have you installed DB browser? I got thumbs up from Ari.
Oh, yeah.
Okay, perfect. Perfect. So then, let me share my screen with you guys. Are you all able to get this screen on your DB browser? Perfect. Now, what we need is we need a data. And I just realized I didn't send you the data, so I'm doing it right now. Minute. Invite? Yeah. Yeah. So this data is highly sensitive because it contains some fun information and a little bit proprietary too.
Is it okay for you to be sending it?
Yeah, I doubt how it would be. Tell me when you see that data. I wanted to make it fun, so. It's nothing serious. We are all here to have fun and learn. All right. So the data has been attached. right. Let me know once you receive that. So that data is a CSV file embedded in that meeting invitation. Let me know once you receive it.
No, I got it.
Thanks, Changi. I received it.
It's for all four because you are not on it.
What?
Yeah, okay, second. Yeah.
It's a well not found.
Yep.
Huh. Okay. I'll try to resend it then.
Oh, it can be. Oh, wait, never mind. So if you open it, so there are three buttons on the attachment. One is download. The second one is open in Google Sheet and third one. So if you click the last two, and you can open it and save it local, like another route.
So if you open it this way, let me share my screen. So if you get to this screen, right,
Mhm.
and then you hit download, then you can see it, right?
Yeah.
Okay. Are all of you able to download the data? I got a thumbs up from Mari. And thumbs up from Shufanat. Link, are you able to download it?
The audio is pretty difficult to hear, Prajwal.
Oh, okay. I'll speak louder then. Thanks for that feedback, Ari. Link, are you able to download that data?
Yeah.
Okay, perfect. Thanks. Right. I'll share my whole screen now. Okay. So then what we need to do is first, we need to create a database because we are using Sufana. Do you have a question?
Nope, sorry.
Okay. So first we'll create a new database and then we'll save it somewhere we want it. For me, I'm saving it in SQL Workshop and I'm calling it Workshop, let's say today, or ISG. Then I'm saving it. Okay, now it is asking for a table. The good thing is that we can go to the file on the top and we can click import and then click on table from CSV file. And from that option, please attach or navigate to the CSV file that you just downloaded. And put a thumbs up once you do that. So for me, this is the data, and I'm clicking open. And we are at this screen. Is everybody at this screen? Good. See one thumbs up. Ari, thumbs up. Link, feel free to use thumbs up. Looks like everybody's are using emojis. And if you have any question, feel free to ask anytime. We learn, we ask questions, we learn as we go. So, and then one of the thing that you should be really careful about is there's this tiny option in the very second row sometimes this option does not get selected. So what you end up having is you will have field 1, field 2, field 3 kind of thing. So keep it checked so that DB browser knows that the column names are at the top, and it will use that same column name as a variable or column name. Now, one of the things that I have to say here is that if you're using other statistical software, you might be used to calling this particular variable name. In SQL, it becomes column name because each of these columns are called column. It can also be called variable. Same thing, but it's a different language, so people call it column instead of variable. Don't get confused. And we are accepting all of the default kind of formatting. And if you want to change the format a little bit more, you can go into encoding, and UTF is the kind of standard format. So we're just following it. And then click on database structure. You should be able to see dummy underscore data listed under your tables. Is everybody able to see that? Give me a thumbs up. Thank you. Sufanat. Thanks, Link. Ari. Waiting for your thumbs up. If you have any problem, let us know.
Do you not see the visual thumbs up?
Oh, sorry, the video was kind of hiding there.
I'll just use the emojis.
Okay, thanks. And then now this, what we just did so far is, congratulations, we created a database. So easy, right? We created a database. You guys all are database administrator now.
Do they automatically assign the, I know SQLite has some simple data types, so like integer, text, do they automatically assign that?
Yes, that's a good question. So yes, they initially assign it automatically. And now if you want to change that, then you can click on modify tables. And then here in the screen, you can change the format. For example, date of birth is formatted as text. Now we can click on that and we can set it to numeric, or we can set it as text. Blob is just a string of characters, right? I prefer to set it as text because we are not going to do any kind of fancy date calculations for now. All right. Now, let's do the real coding thing. Oh, let's first look at the data. Let's use SQL to use the data. Okay, so now go to Execute SQL tab, and then I'll have to send you another email. Actually, I want you guys to type this out, because that way you'll learn. Okay, so here's the SQL code. So first thing is that we need to view the database, right? We need to, in the database, what is a database? This database is actually multiple tables, and each of those tables have some kind of relationship, such as 1-to-1. One row or one ID corresponds to a set of ID. That is a 1-to-1 relationship. A one-to-many is that one table has one ID, but that ID corresponds to many observations in another table. That is 1-to-many. And many-to-many is, again, there are many IDs and they correspond to many different IDs in the other tables. So a collection of different tables is a database. Now, in order to view a database or data system table, to be more correct, we can use select, that is the first statement, star or asterisk, meaning every column and from a name of the table. Now, since this is a basic database, we don't have a schema, right? Schema is when you have a big database, people often assign schema, such as, I'm making this up, but let's say if we were to work in our AHCIE database, so then they might have a schema such as AHC. And if they have a schema such as AHC, then what we would do is that we would say AHC dot and the name of the table. What it really does is that it is just like in Windows, we have a folder path, right? Such as, for example, if we have a C drive, then we do C, backslash, and then name of the folder, say program. And then we have name of the file path, such as dummy data.csv. Think of schemas as same way as the folder path. Instead of doing the backward slash, we just use dot. But in SQL, we don't need to define the drive. We just need to define the schema or the file path before that. In any database that you enter into, generally it is the organization, department, or the team that manages the database will give you a schema. And that is what you're supposed to use in front of the table name. All right. So now with that said, I have to ask you guys one question. How many of you have used SQL before? Ari has, Sufanat has, Link has. Wonderful. Okay, so then you guys all know SQL is the easiest language to pick up because SQL literally is nothing but plain English language in a structured format. So what is that structure? That structure is that your SQL statement always begins from select, and then it's followed by name of the columns or name of the variable. And then it specifies from which table are those columns coming from, and then followed by name of the table. And then a SQL statement. It's a good practice to end it with semicolon. What happens if you don't end it with semicolon? Does it run? Yes, it runs. But does it end? No, it does not. If you don't use a semicolon, oftentimes, and as time progresses by, database administrator will come to you and say, hey, you are crashing my servers. Please use semicolon in your SQL statements. All right. So now with that said, let's look at how to view the top 10 rows. We select everything from name of the table and followed by how many rows you need. The rows for here now, I'm doing just 10. Now, this is a small database, so it will give you the first 10 rows. But if it's a large and huge rows with multi-million observations, then it will give you a random 10 rows, depending on what kind of SQL server is installed on the background. Now,
I have a question.
yes.
So this limit is just random 10, right?
Yes, random 10.
So what if I was the first 10?
So first 10, you'd have to do top 10 in MS SQL. It depends on different programs.
Oh, okay.
Yeah. And then to run your program, you can hit this tiny play button at the top. And now this is a good time here to take a look at what kind of data we have. So first we have is patient ID. We'll use this as an identifier or linking key. And then as the name suggests, linking key is the ID that will link it across different tables. The second column is called name, which has name of the patients. In our case, it's Robert De Niro, Denzel Washington, Jack Nicklaus, all famous people. And then facility name is the name of the hospital that they went to. And in our case, it is Raging Bull, Chinatown, Fences, Line in the Winter, and so forth. And their date of birth. And then we have an encounter date and a medication name that they were under. Now, I have to say that this data is entirely fictional. I created this data set using IMDb's top 1,000 actors, and then also using some of the common medication used in the US. So you cannot do a research using this data. Don't think about publishing your findings, guys.
Seen any of those movies?
Some of them, yes. Have you?
Well, I've seen Raging Bull and Casablanca.
Yeah, I've seen Casablanca. I haven't seen Raising Bull. All right. So with that fun note, let's move to the next piece. So now, often when we are querying the database, what we sometimes need is that oftentimes a table has many different columns, but there are certain key columns that we need to look at, visually inspect them. So in that case, what we do is that we use the select statement, which is select literally, and then name of the column. We want to see the name and we want to see what medication that they were using. And when we run this, we just get 2 columns. Now, at this point, you might have guessed running a SQL query is just like a shopping experience, right? You enter the shopping cart and you enter the shopping cart and you say, select the name of the items in the aisle, and then you give them the name of the aisle, which is aisle A1 or aisle groceries or aisle produce or something, and then you check out with a semicolon. If that makes sense to you, then you can easily think of that way as well. Many of the friends that I know think of SQL in that way. Now, let me introduce to you a new operator that is called like. The like operator is very useful in cases such as we don't want to type out the full value of a column, such as, for example, let's say, I want to know how many people used a drug whose name is something like Prazole. Now, the way we can do it is we can use the percent sign before means that it should have P-R-A-Z-O-L-E at the end, and it can contain anything before that. Similarly, if I add percent sign at the end, it means it can have anything before P-R-A-Z-O-L-E and anything after P-R-A-Z-O-L-E.
So it's containing the string inside of the full column.
Yes.
Like regular expression.
Right. Yes. This is exactly where it came from. The regular expression. You can use that in SQL as well. Now, what are some of the common areas where this is used? One of the common areas where this is used is in terms of doing drug names. People often don't have NDC numbers to pull out a drug information, or sometimes doing fuzzy matching. These are the kind of situation where people like to use like operator. Oh, now let's see what this does. Select that statement and we run it. As you can see, we can see that Robert De Niro got omeprazole and Angela Bassett also got isomeprazole. What that like operator did was it gave us all those rows that contain prazole and something else in the beginning. All right. Now, some of the other conditional operators are and or. And is when we can say that give me where medication name is omeprazole and the patient's name has to be something Nero, like percent sign and Nero. Or we can also do when two conditions are to be met and then you want the results, then you use and. When two conditions are can be met, you want both of these conditions to be met, like you can meet either one condition or the other, then you can use the or operator. Okay. And now let's begin some of the analytical tasks that we have to commonly do in SQL programming. One of the main thing, guys, I really stress you is please use this statement. The count distinct patient ID is that in any creation of analytical data set, you should be 100% sure on how many unique observations there are. And how many unique observations there are often depends on counting distinct patient ID or patient name, something that is really unique. Now, why this is important is because oftentimes statistical methods will focus on only observations that are unique per row. I'll talk about other modeling situations or statistical situations as we move forward. Now, once we know that there are 98 distinct patients, we want to know what kind of medications that they are using. And now you can use the following code to generate a simple table. So what we're doing here is that we're selecting a medication name. What this is doing is it is literally keeping the medication name in the SQL. And then we are saying, give me another column, which will be named as count. And that count will be counting the distinct patient ID for each medication name, and then do that from the dummy data table, and then group it by medication name, and then order that by the highest count. And I'm doing that using DESC. And now when we run it, we see that omeprazole is the most highly prescribed or used drug, with 8 distinct people are using it. And ranitidine, lansoprazole, ispag husk are all the second highly prescribed or used drugs in our table. All right, so up to this point so far, you know how to count distinct IDs, and then you know how to create frequency tables. Now, by this time, I have to tell you that using SQL, you won't be able to do advanced regression analyses, machine learning models, or any of that kind of fancy tools. What SQL does is SQL is good with working with tables, and it is good to this language is really good at pre-processing data. Okay. All right. So we are really halfway through and we have finished the first portion of this workshop. Do you have any questions? Sufana gives me a thumbs up. Is that a yes or no? That is hard to tell now. So, Sufanat, you have no questions? Yes or no? Okay, Ari said no. Good.
Everything's good.
Thank you, Link. Okay, Sufanat, I guess that is no questions. All right. So now we move on to a little bit complex, moderately complex kind of work where we talk about creating the analytical tables. Now, creation of table in SQL has two choices. One is creating a temporary table, and the other one is creating permanent table. A temporary table stays, writes the table in a server or wherever that database is hosted memory. That means once you log out of your computer, that table is gone. Or when that server is reset, that temporary table is gone. Permanent tables, on the other hand, stays, once you create that table, it stays on that server's hard disk or wherever that database is, server is located. Okay, as the name suggests, temporary, it's temporary. It will be available when you work on, and permanent tables will stay permanent even if you log off or something. Now, when do people use temporary tables and when do people use permanent tables? Temporary tables are generally used when a database administrator is a person or couple of persons who are in charge of maintaining that database so that the database runs efficiently and runs without any errors. Determines that they have a shortage on memory, then generally people will give access to write temporary tables. Now, temporary tables does everything that a permanent table does. The only thing is that when a user logs out, the table also goes out and the server frees up some memory, which is available to different users. So that way it stays. Whereas a permanent table is stays there and then eats up your servers, databases, servers memory, and then, but the good thing is that your tables are there. It's, you can reference them always, and so forth. You don't have to rerun your entire script to create tables to work from. All right. So now with that introduction of temporary and permanent tables, we'll talk about analyses. Why we're talking about analysis type is because with different research questions, there are different analysis type. Now, analysis type could be grouped so many different ways, but for the purpose of this workshop, we'll group it into two main ways. One type of analysis is time series or longitudinal analysis. In this time series or longitudinal analysis, a dataset can have more than one row per observation. What it does is that a model such as mixed models or even goes by the name cluster analyses or also goes by the name GEE, generalized estimating equations. What it does is that its estimates are drawn from a cluster of observations. Therefore, in that kind of model, we need to specify the clusters and then run any kind of regression analyses. That kind of data or analysis will give you a robust estimate and robust standard errors and confidence intervals. Now, there's another kind of analysis which is more popular, is the point interval or single observation per row kind of analysis. As the name suggests, it is more common and it is just one row per observations, and there's a different observation in the second row. Therefore, there's no cluster. Therefore, we don't need to specify any cluster, and the common kind of modeling or regression done in this kind of data set is the usual linear logistic regression and so kind of things. One of the problem with this kind of analysis is that the robustness of the estimate is depending on the standards error, which is not standard errors. The robustness of the estimate is dependent on the correlation of the variables, and the standard error and confidence intervals are often unreliable compared to a GEE model for the same kind of data. Okay, that was a little bit of stat talk. Now, coming back to the reality and the pre-processing of the data, we will focus on the single observation per row. Okay, and I have personally felt that and seen that nowadays many jobs give you a data set and they ask you to collapse that time series data into one observation per row. And they ask you to do it in like 30 minutes or 1 hour. That kind of challenges are going on. So here's how to do it. So first thing is that we need to create a table. So the creation of the table starts. Yes, Ari, you have a question. Looks like.
Yeah, I had a question on the above. So
Yes.
I don't know if, I think you might be familiar with like the tidyverse in R
Yes.
by Bradley Hickley or
Yep.
Bradley H. And in those packages, there's a library that's meant to transform tables in longer formats and then more shorter formats. So is it correct to say for that first type time series analysis, it'd be transforming the table to a longer format, so more rows on the date variable? So if,
Yes.
okay,
Yes.
I don't know, maybe that was just a way I'm thinking about it, but I'm trying to get clear on
Yeah.
what that's trying to do.
I mean, ask any questions, right? So since you asked that question, I'm guessing you are a R user first and then SQL user second, or people generally tend to think of languages in terms of what their first language is. For example, if you're familiar using R, then you will think of other languages in comparison with R. And that is natural. So there's no problem with that. And like you said that pivot longer turns like multiple rows per ID, which is creating that data again in a time series format. A time series format, again, I'll add this little plug, is that it is a useful dataset type because it captures all of the time series observation per person. So any analytical methods that uses that actually captures the cluster-wise correlation and time dependency of the observation. So it is a useful technique, but it is often complicated technique because in terms of interpretation is where it suffers. So that's why people often default to using the one person per row kind of observation, because then you could do frequency tables, then your interpretation is easier. Your estimates is kind of, again, dependent on the correlation, but more or less, it's kind of robust and generally accepted. But your standard errors and confidence intervals would be off. But then there's no way to tell how strong a standard error or CI is, depending on like how accurate your predictions are. All right. So enough of the stat talk. Unless people have questions, let me know. Okay. And then let's create our first table. So in order to create the table, the first command we have to give it is create table T0. And now I'm using T0 because I ran out of names of the table. So what I'm doing is T stands for table and 0 stands as my first table. So I'm calling it T0. And now the other thing that I have to tell you is that creation of table, and when we are writing this, we are assuming that we have to run our SQL script over and over and over again. So in order to avoid getting error, I'm using another script that says drop table if exists T0. As you have guessed, this is in plain English, it means that, hey, SQL, if there is T0, please drop that table. And that's it. That's what it is doing. If there is no T0, it won't do anything. And then in the second line, it says create table T0 as, and we're giving here the command, and here is the first window function. Let's first look at the data so that it's helpful. Okay. So as you can see here, we have two observations for patient ID 1. Now let's look at what is different. So patient ID is the same, name is the same, facility name is the same, date of birth is the same. Encounter date is different. Why? Because the medication name is different as well. Okay. And then we see patient ID 6 also has 2 rows. Everything is same, but we have 2 different encounter date because there are 2 different medications. Now, let's solve this. Now, there are many ways to solve this and flatten it out. I'm showing you the longest way because that is the most intuitive way to understand it. And once you understand that, you go a different route. First is that I'm going through the longest route. So then I'm picking up the minimum encounter date as the index date. The index date is the first date. A date is generally a term coming from epidemiology and generally means the first time an event or anything has happened, or disease outbreak has happened or anything. So I'm saying SQL, get the minimum encounter date and then look only within the same patient ID. I'm doing that by saying the command partition by. And then what I'm saying SQL is that once you grab that minimum value from encounter date, write that value in a new column called index date for one patient ID. Okay. Now, let me show you what that does. Let's run it. Oops. So more rows. There. So it ran without any errors. And then, now let's see what it did. So I'm telling it to create the index date. So the index date has been created. I told it to pick the minimum value. So the minimum value is 1439 and the maximum value was 2021. It picked the minimum value and it wrote twice for each ID. Right? I'll leave that. I'll leave a moment. I want you to guys take a good look at this table. Any questions?
I have a quick question. So when we say the partition by, like what's the difference between partition and group by?
Yes, that's a good question. Thank you, Link. So partition by is saying, can I use annotate? Yeah. So partition by is saying SQL only look at this ID. So for example, we said partition by ID, right? If we had said partition by ID and name, then it would have taken a look at only this is one. Do this minimum calculation at a single time. So take the minimum value only for this chunk of row. For example, in our case, we said, let me erase this first. So in our case, we said partition by ID, right? So what the SQL Server SQLite did was that it looked at patient ID and said, oh, this is patient ID 1. I need to stop here because if I go below, then patient ID 2 starts. Then it draws a line like this. And then it says, okay, what I need to do is then pick a minimum value from encounter date. Then it looks into encounter date. Oops, yeah. So then it looks into encounter date and then it picks the minimum value, which is this one. And then it writes it over here. Now, group by. What group by does is that group by collapses the observations by each ID or each whatever name of the column that's specified in group by. For example, if you say group by, then what it will do is that it will disregard any second column and it will only take the first column and it will collapse it. So group by is generally used when you are trying to create or collapse data into a set of unique observations. I generally tend to think like that. But then group by does not do any kind of analytical procedures.
So with group by, you would have gotten, if you just looked at patient ID 1, you'd got one row as opposed to 2 rows with partition.
Right.
Oh, okay.
For example, now I have 2 observations, right? Then if I had said group by and had not mentioned the encounter date, then it would have already collapsed this data. Oh, and encounter date and medication name, then it would have collapsed it into one row. Yeah, that's a really good question, Nick. Thank you for asking that.
How are you drawing? Is that through Zoom?
Yeah, I'm using the annotate function of Zoom.
Okay.
And I need to get out of my annotate. Okay. All right. Now with that gotten squared away, let's move on to the next part. Now, let's remember what is our goal. Our goal is to create a data set with one row per observations. Okay. Now, the way to do that is what we need to do is like Ari said, is we need to transpose our data set. Now, what I'm doing here is we are using a case when statement. If you are used to using R or SAS or Stata or something else, these are generally covered by if and else statement. In SQL, that conditional if and else statement becomes case when statement. Now, what I'm saying here is case when index date is equals, this index date is equals to the encounter date, then give me the name of the medication, else make it null, and then write it as med1. Similarly, if it's not equals to encounter date, then write as medication name, but name that as med2. And then I also want to capture the date. So I've done the same thing, but this time it is writing the encounter date. And now let's run it. Boom. You can see that I generally like to keep my old columns with the new columns because that way I can visually inspect what is going on. And then here you can see that the omeprazole index date was similar, so it was written as med1. In med2, the index date was not equal, so it wrote as semimethicon in second row. And then it also gave me the value for the second encounter date. Any question? Yes.
So currently, for the first two rows, we can say Robert De Niro have two medications.
Right.
It's also two separate rows.
Yes.
So is it possible to merge these two into one?
Yes, and that is what we'll do in our next step.
Okay, cool.
Yeah, I'm doing this in a step-by-step way so that people know what SQL is going through, and people like don't get confused. Oh, how did this happen? Where did the middle step go? So I'm showing all of the steps here. And also, if you code it this way, it is called defensive coding. Now, the other way of doing a defensive coding is commenting everything. And you do it like step by step. It is also another style of doing defensive coding. So you can mention in your cover letter that you prefer or you like doing defensive coding. All right. By the way, defensive coding means commenting and like listing out its steps and checking throughout. Now, like Changi correctly pointed out, you can see what is going on, but what you need to do is now you need to collapse that two observations into one, right? So the way that we do that is that we use another window function, which is max, which is opposite of minimum. And how the SQL server evaluates the max function is that if there's anything null, null has the least value, and anything, any column or cell that has any value has the maximum function. And that again depends or evaluates against if there's number, then it will be highest number. If it's word, then SQL will pick out the longest string of words as the max value. Okay. All right. Now then what we do is just as above, we do max in a single partition by single ID, look at single ID, and then write it over and over again for each ID. Now, here's what happens. As you can see, omeprazole is written twice. Semimethicone is written twice. And this date is also written twice. Right? I'll let that set in. I'll take a pause. Think about this. This is a very important step. And in the next step, we'll get rid of all the duplicates.
The question, so
Yes.
how did this medicine to index date come from? So we only have, oh, never mind. I just saw it.
Mid 2. So we're,
I just saw the column.
yeah. Okay, perfect. Okay. What we have done is that we have captured the first date of a medication and related name of the medicine. We have also captured the second date of that medication use and also related medication. And we have written it twice. Now, the only thing that remains is to get rid of that duplicate. And how we do that in SQL is kind of tedious way. We specify name of each column that we want in our new data set. In this case, we leave out names of the column that have two different values, such as medication name has two different values, encounter date has two different values. So I'm leaving it out. I'm only using those columns that have the same value. See, for example, patient ID has same value, patient ID. And then name has same value. So I'm specifying name and so forth. Now, for this new column that I'm calling as med1, I'm naming that as med1, renaming that as med1 in this step using as. Okay. And then I'm using another keyword here, which goes by distinct. I'm saying select distinct and set of column name. So what it does is it gets rid of all the duplicates. Let's see. Boom. See what happened? We now only have one Robert De Niro, but we have both of his medication and related dates.
How, in a real data set, you might have an arbitrary number of medications and encounters. How, just in a generic way, how would you code for that? Like if you had to do med 3, med 4, med 5, different patients had different amounts.
Yeah. So in SQL is an iterative language, declarative language. So we have to literally type it out. Yeah. Like I know in R, there's a function that says ends with. SQL does not have that kind of function. In R, we have ends with, starts with, and we can also specify numbers, right? In SQL, often we don't. What I know that, okay, let me finish and then I'll let you go. In Netezza, when we do a group by statement, we can specify 1, 2, 3, 4, 5. So that's, it references the columns by numbers, but in MS SQL, we cannot use those numbers. Yeah, all right. That's what I wanted to say. Ari, you go ahead.
Okay. Also, for example, if you had a data set where the maximum number of encounter medications for an individual patient was 150. And most patients, let's say, had around 5 medications, but one had 150. You'd have to find the max. If you're trying to collapse them into one observation per patient, would you have to find the max and then hand code it? Or is there a faster way to?
Right, right. That's a really good question, and that's a practical one too. So coming straight to the answer, what I would do in that case is that I would create, remember the table that I showed you how to create? Where did that go? Yeah, this one, the frequency table. I would use this column to create distinct list of those medications, and then I would hand code to transform my data this way. Yeah, it is tedious.
Okay, thank you.
Sure. Any other questions? Okay, I'll take that as a no. Now, looks like, guys, we have one observation per row, right? Let's do some quality check. So let's count the number of distinct patient ID in my final table, which is the T3, 98. Okay, so now can anybody give me a guess on how many rows of observations should be there in our new data set?
98, right?
Exactly. There should be 98 because every row is unique. Now let's find out. Boom, 98. So that means we have successfully collapsed the data set into one observations per row. Now, sometimes that doesn't happen. Sometimes we are missing out those edge cases that we forgot to collapse and generalize. In that case, I'm giving or sharing the following code with you to investigate those kind of edge cases. Now, what is this code? Is it any fancy code? No, it is just creating a frequency table. What it is doing is that it is giving me patient ID, and I'm counting the patient ID. And then, like Link suggested, I'm using the group by to group each of those patient ID. And then I'm telling SQL, show me only those have more than one value. So then when you do this, it will show you the patient ID that has more than one row. Let's run it for now. It's empty. Here it says 0 rows returned in 4 microseconds. Why? Because there's nothing. Now, once you identify that patient ID, you can put that particular patient ID and see that patient, how that patient ID changes or has unique characteristics that the other observations didn't have. And then you can, again, suitably adjust for it. Okay. All right. So that is what I wanted to show you guys, the basics on SQL. I have purposefully not included joins in this iteration, but if you have any questions regarding join, I can show them to you as well. I know we are on the dot of time.
Will you send out the SQL script?
Yes, I can do that.
Awesome, thank you.
Sure. All right. Any other questions, guys? Sufanat?
No question. It is very useful.
Thank you.
Yeah, thank you.
Yeah. Yeah, I hope you enjoyed. And yeah, I have not included the joins statement again, but if you Google it, you can find it. One of the best resource on SQL, and I use it so many times, is the Stack Overflow.
Highly recommended.
Yeah, so feel free to use Stack Overflow, ask any kind of questions. If you look at one Stack Overflow questions, you'll see how people ask questions, how people discuss, and those kind of things. And you can like ask your question in similar format and expect answers. All right. So with that, that is the end of today's workshop. Hope you enjoyed. And if you have any follow-up questions, feel free to email Change or me. And then we'll be happy to get you back. We'll share this SQL script with you shortly.
Good, thank you.
All right.
Thank
you.
you.
You guys.
Bye.
Bye. Thanks.